Hello, in this video we're going to think about how negation and conjunction interact, which turns out to be a somewhat complicated topic. So we know that there's a difference between the negation of a conditional and a conditional that contains a negation, say, in its antecedent, and the same thing is going to turn out to be true with conjunction. So let's suppose we have P and Q, both sentences, because they're sentence letters. Well, we know we can form a conjunction out of those, and then we could put a negation on there, and that's the negation of a conjunction. But also, since P and Q are sentence letters, we could put a not P, we could put a not on the P, building not P, and the same thing with Q. And then we could put those together to form a conjunction, and so then we have a conjunction of negations. And so this is similar to the issue with the conditional. Where is the negation going? Is it going outside of the conditional or inside of the conditional? Where does the negation go? Does it go outside of the conjunction or inside of the conjunction? And what difference does that make to the meaning of what's said, of what these sentences mean? So, in fact, there are lots of places we could put the negations. We could put them on either conjunct or both, and then we could negate each of those. So there are many places we can put negations, and of course, as it turns out, although it may not be obvious, in fact, these all say different things. And so in particular, it's not obvious how the negation, when it's outside, moves inside, because when the negation is outside, you can't just easily move it inside and turn it into a conjunction. We'll talk about that later, why that's so. And of course, we can drop the parentheses on the left column because those are external parentheses, but not the ones on the right because those parentheses are not external. So let's look at this contrast case and explore it to understand what negation and conjunction do when they interact with each other. So we have the negation of a conjunction, negation of P and Q on the one hand, and we have a conjunction of not P and not Q on the other hand. And so here are their trees. So let's consider a situation. We know that in this situation we know two things. We know that Carmen is not in San Diego, and we also know she's not in Las Vegas. So S, symbolizing Carmen is in San Diego, that's false. Not S, symbolizing Carmen is not in San Diego, that's true. And similarly, V for Carmen is in Las Vegas would be false, and not V, that would be true. So what happens if we put not S, if we take the conjunction not S and not V? Well, both of its pieces are true because not S is true, and also not V is true, and so that conjunction is true. Good. So when we think about what the first one says, well, it's a conjunction, not box and not circle, and it says not box and not circle. And so a different way of saying that is that it says both box and circle, both of the atomic pieces are false. Okay, well, what about the other one, the negation of a conjunction? Well, let's consider a different situation. Carmen is in San Diego and she's not in Las Vegas. So in this case, S is true and not S is false because they have opposite truth values, whereas V is still going to be false because she's not in Las Vegas, and so not V is going to be true. Okay, well, what about S and not V? Well, that should be true, right? Because both of its pieces are true. S is true, she's in San Diego. Not V is true because she's not in Las Vegas. So S and not V, that's true. Good. That's fairly straightforward. Let's look at some other ones. S and V. Well, S is true because she's in San Diego, but V is false because she's not in Vegas. And when a conjunction has a false piece, it's false. So S and V is false. What about not S and V? Well, that's the negation of a conjunction, right? It's not S and V is the negation of S and V. And we know that when we have a sentence and its negation, they have opposite truth values. So even without thinking about how it's what's going on with the pieces, we can tell that this has to be true because it has to have the opposite value of S and V. S and V is false, so not S and V is true. And that should make sense. Is it the case that she's both in San Diego and in Las Vegas? No, because she's not in Las Vegas. And so that the negation of the conjunction, that's true. But what about not S and not V? Well, not V we said is true, so the right part of that conjunction is true. But not S, no, that's not true, right? S is true. She's in San Diego. So when we say she's not in San Diego, well, that sentence says something false. So this conjunction, its left piece, not S, is false. So that's a conjunction with a false piece, and therefore it's false. And so now we can see that not S and V on the one hand, and not S and not V on the other hand, those say different things. Not S and not V says both of its pieces are false, whereas not S and V says the conjunction is false, and there are many ways that could be. Let's look at how this works with the trees, the parsing trees. So we know that S is true because she's in San Diego, and V is false because she's not. So not V, that's true. Can we tell whether or not the conjunction is true yet? No. For the conjunction to be true, both pieces have to be true, and as it turns out, not S is false because it has the opposite truth value of S, which is true. So we have not S, which is false, and not V, which is true. So the left-hand part is false, and so the whole thing is false. Right? Not S and not V, that's false. Why? Because S is true. And in fact, we don't even care about what's going on the right-hand side. All that matters is what's going on the left-hand side. Given that S is true, not S is false, and so the whole thing is false. What about the negation of the conjunction, the other one? Well, S is still true. She's still in San Diego. V is still false. She's not in Vegas. So S and V is false. So the negation of that has the opposite truth value, and so it's true. Right? When we say not S and V, that's correct. It's not the case that she's in both of them. But if we say she's not in S, she's not S, and also not V, she's neither in San Diego nor in Vegas, we've said something's false because she's in San Diego. We can see that these two sentences have different meanings in a slightly different way. Here we have the 4 different ways that the truth and falsity of circle and box can be combined. They both might be false. Box is true and circle is false. Box is false and circle is true, or they're both false. So we know that box and circle is true when both box and circle are true, and otherwise it's false. And we know that the negation of box and circle has the opposite value, truth value of box and circle. Right? The negation of a sentence has the opposite truth value of the sentence. And so negation of box and circle is false when both pieces are true, because in that situation box and circle is true. But negation of box and circle is true everywhere else, because on all the other rows, box and circle is false. So we can see that it's relatively easy for box and circle to be true. The only way it's false is if both box and circle come out true. Otherwise, if either box or circle are false, then not box and circle comes out true. What about the negation of box and of circle? Well, so we know that negation box has the opposite truth value of box. So wherever box is true on the first 2 rows, not box is false. And on the bottom 2 rows where box is false, not box is true. And then not circle, well, that has the opposite truth value of circle. So on the first and third row where circle is true, not circle is false. And on the second and fourth row where circle is false, not circle is true. And so then if we think about, well, not box and not circle, well, that's a conjunction. It's a conjunction of not box with not circle. And so the only way for not box and not circle to be true is for both of the negations to be true. And that happens only on the bottom row. Otherwise, at least one of the negations is false. And in that case, the conjunction is false as well. And so we can compare then, say, well, on all those 4 rows, we can see that on many of them, not, on the one hand, not box and circle, and on the other hand, not box and not circle, they have different truth values. They agree on the top row. When both box and circle are true, both of them are false. And when both box and circle are false, then the negation and the conjunction, the 2 big sentences, are also true. But on the middle rows, when when box and circle, one of them is true and the other is false, then they disagree because, as you can see, right? So we can see that they say different things. Not box and circle requires that at least one of them be false, whereas not box and not circle requires that they both be false. So the conjunction, it's more demanding. It requires that both box and circle are false. That's not box and not circle. Whereas the negation says it's not the case that both box and circle are true. And so it's true. What does it say? Well, it says either box is false or circle is false, or they both are. And so it's not as demanding as the conjunction is. So we can see that the negation of a conjunction and the conjunction of a negation are different sentences, obviously, but we can see that they say different things as well. And so we want to keep that difference in our head separate when we're symbolizing and when we're working with these sentences and derivations. Then you might ask, okay, what does not box and circle mean? Can we move that negation inside in any way? Well, Negation distribution is tricky, and we can think about that from math. How negation distributes depends upon what the internal symbol is. So if we have negation, or negative, of 5 plus 4, well, we can move the negative inside and put it on the 5 and the 4, and we get negative 9 either way. So there, the negation distributes over addition. But negation doesn't distribute over multiplication, right? So negative 5 times negative 4, that's positive 20. But negative of 5 times 4 is negative 20. And so negative 5 times negative 4, that's different than negative 5 times 4. So we know in math what happens with negation and an operation like addition or multiplication. It depends on how addition and multiplication work. The same thing is true with in logic with the conjunction and the conditional. So in particular, you might think, oh, well, I'll just move the negations in. And we've seen that you can't do that with the conjunction, and it also isn't true with the conditional. So how do we move the negation inside of a conjunction or inside of a conditional? Well, I'm going to tell you that, in fact, one way to do that is negation of P into Q. That's equivalent to, always has the same truth value as, if P, then not Q. And what about negation of if P, then Q? Well, that always has the same truth value as P and not Q. Now, we're not in a position to prove that these are equivalent right now. We'll be doing that later in the course. Right now, we can't prove that they're equivalent. So the main thing we want to take away from this is, okay, what does not box and circle mean? What does not box and not circle mean? And, oh, they mean different things. They do not always agree on their truth value. Sometimes one is true and the other is false.